In the first video clip, we saw how we could simplify a surd, something like, say, the root of 50, and we obtained this as 25 times 2, breaking the two numbers such that we could find the square root of 1 and we can find the square root of the second one, and when we finally arrived at 5 root 2. Also, if I have something like root of 8, this will give us the root of 4 times 2, and that will be the root of 4 times the root of 2. The root of 4 is 2, so that will give us 2 root 2. Our objective now is, how can I play from 5 root 2 back to root 50? How can I play from 2 root 2 back to root 8? Let's look at 5 root 2, for example. 5 root 2. If I want to reverse the process, I'll simply look at 5 first, since it's out there, as I have to express you as a square root first. And that means 5 will be the same thing as the root of 5 times 5. Yes, well, if I take the square root of this, I'll get my 5 back. And of course, I have my root 2 still standing there. I say, okay, this is actually root of 25 times the square root of 2. And then this is the square root of 25 times square root of 2. And the rule says 25 times 2. Remember, if you can walk from left to right, you should be able to walk from right to left. And that's exactly what we are doing here. We actually walked initially from root 50 to 5 root 2. We have just taken the same process and we have returned from 5 root 2 back to root 50. Let us see how we can apply that. Of course, you can see this. The first one is going to give us root 8, but let's try it out. And then we'll treat this, there, and there. Let's take the first one. You can see that 2 root 2. Our 2, which is outside the square root sign, is first and foremost given a square root sign. So we have written our 2 here as 2 times 2 with a square root, which is a what? Which is root 4. That's our root 2 still standing. Now joining this together using the first rule that says that root m times n is root of m times root of n. So I can also walk back by saying that root of 4 times root of 2 is therefore the root of 4 times 2. And that gives me root of 8, which means that 2 root 2 can be expressed as a single surd of just what? Of just root 8. For 6 root 5, I take the same procedure again. I try to do what? Cover my 6 with the square root sign, and you see it becomes 6 times 6, and that is what? Root 36. Of course, and that's our 6. Then times root 5. And then we play the reverse from right to left. Root m times root n is root of m times n. So root 36 times root 5 is root of 36 times 5. And that gives us root of 180. So root of 180 is the same thing as 6 root 5. So you can say root of 180 is a single surd of 6 root 5. We look at 3 root 2. Let's do that. 3 root 2. By now you should be getting smarter. It means I'm going to turn this 3 to its square root form, and that's obviously going to be 9 square root. Yes, I don't have to start saying 3 by 3. And then I have times root 2. So that's my 3. Sorry, this is supposed to be 2. Now I merge the two of them. That gives me a root of 9 times 2. And that's what? Root of 18. Sometimes some of us just fly from here straight there, convert the 3, square it becomes 9, and drop it inside the square root sign without going through this step. There's no problem. And finally, we have there, yes, you can see what I've just said, 4 root 3. We know first we have to deal with the 4. The 4 is going to become 16, and finally find the step inside the square root sign. So that's it there. Instead of going through all that process of doing 4 times 4 and then times root 3, we just drop 16 in there, which is the square root of 4. So which is the square of 4. And then 3 times 6, right to left, gives us root of 48, which is the single surd of 4 root 3. I'm sure we are okay with that. So that's the reverse of what we did in the first slide. First slide we simplified. Now we are not simplifying. Should I say we have compounded our problem? Sorry about that. Now we are introducing 2 more rules. Remember, we are looking at the algebra of surds, basic operations we can perform on surds. We have seen this, though we have not actually used this yet, but the same basic operations can be performed. Here we are looking at a special rule that if we have the root of a number, say 7, and multiply it by that same root again, 7, of course you will agree by that first rule that this will be 7 times 7, which is what? The root of 49. And root of 49 is 7. Oh, so I have root of 7. I multiply by the root of 7. I simply just have my 7. Just throw away the square root sign. Root 7 times root 7 is 7. That's what this rule is saying, that the root of a times the root of a is simply our what? Is simply our a out there. Let's treat some examples on this. Here we have root of 2 times root of 2 will give us what? Will give us root of 4, and that's 2. So root 2 times root 2, just apply the rule, will give us 2. There again, root 3 times root 3, you will agree, will give us just 3. You can see the procedure. 3 times 3 is 9. Square root of 9 is 3. Now I want to look at, okay, that's root 5 again times root 5. You will agree we don't have to go through that long procedure. We just deposit 5 there. Now let's look at the next rule. This is fundamental algebra. Root m times plus root m is 2 root m. Yeah. This is like saying x plus x. Algebra simply says this is what? This is 2x. So we apply that. That's it there. In algebra we have a plus 3b minus 5b minus 2b, minus 5a minus 2b plus 11b. What do? We simply collect our like terms. I think we learned this first year in the secondary school. We collect our like terms. A first, minus 5a, pack all the b's together, 3b minus 2b plus 11b. A minus 5a is minus 4a. 3b minus 2b is b plus 11b. That will give us 12b. We're going to apply this in our basic surd operations. As you've seen there, root m plus root m can give us 2 root m. So that's it there. I think there's a little mistake in our slide. I think this should have been a. Sorry, this should have been a. So that should give us 7a there. Please, you can take care of that. Now let's look at this. Let's simplify this. Here I have root 7. This is root 2. This is root 7. Take my roots as if they are my a and b. So I collect like terms. I say, okay, all root 7 come together. Root 7 minus 5 root 7 plus 11 root 7. And then I take the root 2's. 3 root 2 and minus 2 root 2. This is like say 1 root 7 minus 5 root 7. You agree to give us minus 4 root 7. Then plus 11 root 7. Minus 4 plus 11 should give us 7. So that's 7 root 7. And then 3 root 2 minus 2 root 2 should just give me a single root 2. 3 minus 2 is 1. And that's positive 1 root 2. In algebra, you don't have to write the 1. So that's it there in a simplified form. Very neat. All root 7s packed together. You see them there. All root 7s packed together. All root 2s packed together. And we have minus 4 plus 11 to give us 7 root 7. And then plus root 2. Yes. In the next video clip, we are going to address all these problems from question 1, 2, 3, 4, 5, 6, 7, 8. So we'll be simplifying. In some cases, we're going to simplify. After simplifying, we'll do what? We'll play some algebraic operations and then get an answer for each of that. So let's see in the next video clip.